Hello and welcome back to the drawing board with me, Elliott Griffin. Today I'm going to talk to you about stiffness and preload. Stiffness is a measure of a member's resistance to deformation, and we're going to focus mainly on axial stiffness, but the other ones that you may come across are bending and torsional stiffness. And preloading is something that we use to mitigate deflection of our props when they're in the ground. So stiffness in its simplest form can be described like a spring, and you may recognise this diagram from an experiment that you might have done in school. It's a simple spring with a weight W on the end. And we learn from this that when you apply a weight or a force to a spring, that it deflects by X amount of distance. K is then described as the spring constant or the spring stiffness of this system. And then we later learn that K can be defined not just by experimentation, but it's a product of the cross-sectional area of a member multiplied by the Young's modulus of the material that that member's formed from and divided by the length of the member. This then gives you a stiffness of a member, which can be used to find out how much it will compress or stretch under a given loading. Now, in hydraulic propping, it's not as simple as a single spring. Steve's talked in previous videos about the hydraulic column of fluid that's at the end of our props that we use to fine-tune the length. And this is more often than not a lot less stiff than the rest of the steel extensions that are in the prop. So we have two springs in series, and to calculate the overall stiffness of this prop, we have to take the reciprocals of both springs. Now, when we apply this formula to here and rearrange to make the resultant stiffness the subject, we end up with 1 divided by all these elements. We've got the length of the hydraulic column, the Young's modulus of the hydraulic fluid, which we've obtained from test data, and the area of the ram bar. And we've also got the length, Young's modulus, and the area of the steel extensions that we're using in that prop. This then gives you a resultant stiffness for a single prop, which can be used to calculate how much it's going to deflect under a load. Now, when you're talking about an excavation, you're not just talking about a single prop stiffness. You're usually talking about the system stiffness, so it's made up of multiple props in that excavation. And to calculate the system stiffness of multiple props, it's a product of the stiffness of the props themselves, but also the angle of the props and the spacing between props, and also the loading conditions sometimes. This will then give you the system stiffness of your excavation support. And depending on if you're using a structural steel or a hydraulic support system, then you'll get different loadings and also different deflections, because hydraulic systems are a little bit less stiff than steel systems are. So this is when we use preloading to mitigate the deflection that happens due to that lower stiffness. Now, to work out the preloading that we require, we can rearrange the formula for Young's modulus, and we concentrate here on the hydraulic column because this is the bit that we've got control over. So, to calculate the axial deflection of a single prop, we take the force that's applied to that prop, the area of the ram bar in that prop, the length of the pump out, and the Young's modulus of the shoring fluid. This will then give us the deflection of a single prop under loading in an excavation. And we can do this for multiple props in the excavation and preload it to reduce the deflection everywhere. We then take this deflection and we divide the force that's applied to the prop by it. We can then multiply this by the amount of deflection that we need to reduce, which gives us a force that will be the pre-stress load that we need to put into the prop to mitigate the deflection that's happening. And we know that this is a linear relationship with pressure, so we can put the pressure straight back into our struts and stop the excavation from moving in too much. I hope this has given you a good outlook on stiffness of hydraulic propping and preloading. I hope you liked the video and subscribe to the channel, and join us next time on Back to the Drawing Board.